رحيم أعزائي طلبة وطلبات شهادة الثانوية العامة قسم رياضيات لغات، السلام عليكم ورحمة الله وبركاته. موعدنا اليوم درس جديد في مادة الاستاتيكا وهو بعنوان parallel forces. طبعا احنا عارفين مادة الاستاتيكا هي احدى فروع المادة التطبيقية وعليها 30 درجة من 60 درجة اللي هي درجة المادة التطبيقية. وعرفنا قبل كده ان الاستاتيكا هو علم السكون، بندرس كل جسم ساكن في الواقع اللي موجود بيننا. ان شاء الله النهارده هناخد parallel forces or parallel coplanar forces. Welcome my dear student in our math program for secondary 3. Today we are taking new lesson in static. It's called or its title parallel coplanar forces or resultant of two parallel coplanar forces. My dear student, what is the meaning of parallel forces? We have two types of parallel forces, like and unlike. What's the difference between like forces and unlike forces? Like forces in the same direction, but unlike forces in different direction. My dear student, look at resultant of two parallel coplanar forces. My dear student, look at in the opposite figure, we have two forces, F1, F2, are parallel, act at A and B consecutive, and R is called resultant of the two forces with direction C. We have two forces, are parallel in same direction, like forces acts at A and B and R acts in C. What is the resultant of F1 and F2? Look at, my dear student. The resultant is a force in the same direction as two forces. R is called resultant of the two forces is a force in same direction as two forces. Its magnitude is equal to sum of magnitude of the two forces and direction. My dear student, R1 R equals F1 plus F2, but in its direction or its line of action divided the distance between the lines of action of two forces. In the inverse ratio to their magnitudes. What you mean, my dear student? We know that F1 times AC equals F2 times BC. Therefore, F1 over F2 equals BC over AC. My dear student, we have two forces, F1 and F2. R acts at 2 points A and B, and R is called resultant equals F1 and F2. Its direction, same direction of parallel forces. We know that F1 multiply AC equals F2 multiply BC. If we find the ratio between F1 and F2, therefore BC over AC. Example. Two like forces of magnitude 5 and 7 newtons act at the 2 centimeter. My dear student, we have two forces. Our magnitudes 5 and 7 newtons act at the 2 points A and B, where AB equals 36 centimeter. What is the required? Find the resultant of the two forces. Solution. Look at, my dear student, we have two forces, 5 and 7, are parallel in same direction, act at A and B, such as AB equals 36 centimeter. What is the required? Find the magnitude of R and direction of R. Let's see vector, unit vector in direction of the two forces. Therefore, we can represent F1 vector, FC vector, and F2 vector, 7C vector. Therefore, we deduce that R vector or the resultant vector equals F1 plus F2. By summation, 5C vector plus 7C vector equals 12C vector. This is called resultant of the two forces. When I identify the point of action of the resultant, look at my dear student, AB equals 36, but R act at a point C belongs to AB. What is the length of AC? Or what is the length of BC? We suppose, my dear student, C belongs to AB line segment, there AC over CB equals 7 over 5. This ratio between AC over CB equals opposite ratio of the forces, 7 over 5. We know that, my dear student, AB equals 36. Therefore, AC over 36 minus AC equals 7 over 5. By using, my dear student, by using cross multiplication, therefore, we deduce that 5AC equals 252 minus 7AC. Therefore, my dear student, 12AC equals 252, or AC equals 21 centimeter. My dear student, we can calculate AC by other method. We can suppose or let AC equal X. Then BC 36 minus X. Then multiply 5 times AC equals 7 times BC, or 5 times X equals 7 times 30C minus X. Then calculate the value of X, or AC equals 21 centimeter. What did we deduce? We deduce that magnitude of R equals 12 Newton and act at a point C, which is 21 centimeter from A, or which at 15 centimeter from B. Then magnitude of the resultant equals 12 newtons. It acts in the same direction of the two forces, and it acts at a point which is 21 centimeter distant from point A. Now we are translate to another title, resultant of the two unlike forces. My dear student, look at in the opposite figure. F1 acts at A, F2 acts at B in opposite direction, and are resultant of the two forces, its direction with the biggest force. F1 and F2 are called unlike, parallel, coplanar, unlike forces. Why? Because opposite direction. Two forces F1 and F2 are parallel and unlike forces. F1 and F2, two parallel, unequal and unlike, in the opposite direction, act at 2 points, A and B. In a rigid body, and the resultant is R. What is R? R equals F1 plus F2. But remember, my dear student, F2 equals, in this case, negative F2. Why? Opposite direction. And acts as a point C, which divided AB externally. Look at the point C, divided BA externally, two parts, BC and AC. In an inverse ratio of the magnitude of the two forces, if we have F1 more than F2, therefore we deduce that AC over BC equals F2 over F1. Remember, my dear student, we can, by using cross multiplication, deduce AC, F1 times AC equals F2 times BC. F1 times AC equals F2 times BC. Remember, my dear student, if we have two forces unlike or in opposite direction, we can find R by using F1 minus F2. And don't forget, in this case, F1 more than F2. And we deduce also the resultant is with direction F1. Note that the resultant of the two unequal and unlike forces is a force in direction of the force of the greater magnitude. Look at, my dear student, its magnitude and its line divided the distance between the line action of the two forces externally. From the side of the force of the greater magnitude is an inverse ratio to their magnitude. Look at, my dear student, important example. Two unlike forces of magnitude 40 and 100 newtons, and the distance between their two lines of action is 240 centimeters. Remember, my dear student, two forces unlike. What you mean? Excellent student, opposite direction. Find this resultant. Look at solution. We have two forces. The biggest force is 100. The smallest force, 40. 100 act at A. 40 act at B. The force 100 acts at point A. The force 40 acts at point B. The distance between two forces or AB equals 240 centimeters. Remember, my dear student, the required find the magnitude of resultant. Look at R at C. R with the biggest forces. Biggest force is 100. Then we deduce that. Let's see vector, unit vector, and direction of the greatest force. What is the greatest force with 100? Therefore, my dear student, F1 equals 100 C vector, F2 negative 40 C vector. R equals what? F1 plus F2. But in this case, F2 negative 40. Therefore, by substitution, about F100 C, F2 negative 40 C, answer is 60 C. Therefore, the resultant of the two coupler forces unlike 60 smaller than the biggest force. Remember, my dear student, in this case, R is smallest 100. Why? R equals 60. And in same direction of the biggest force. And when we determine what is the length of AC, we know that CA over CB equals what? Equals F2 minus over F1. CA over CB equals 40 over 100 or 2 over 5 by simplest form. using cross multiplication, we deduce that AC equals 160 centimeter. Remember, my dear student, the resultant is 60 Newton and act at distance 160 centimeter from point A or 400 centimeter from point B. This resultant of two forces alike. Therefore, we deduce that the magnitude of resultant is equals to 60 newtons and its direction in the same direction of the two force 100 Newton. It acts at a point belongs to BA ray, doesn't belong BA line segment, and it is 160 centimeter apart of A. My dear student, we have two types of forces, like forces and like forces. When we find resultant of two coplanar parallel forces, we know that R equals F1 plus F2. What is the direction of the resultant? In the same direction of two parallel forces. But my dear student, if we have two unlike forces, then the resultant must be with the greatest force, and summation equals F1 minus F2 or F1 plus negative F2. Remember, my dear student, we have ratio between F1 and F2, inverse ratio between the parts of the two sides. Don't forget, my dear student, the direction of the resultant in coplanar forces in same direction of forces, but direction of resultant of unlike coplanar forces with the greatest force. If F1 more than F2, then direction of R with F1. If F2 more than F1, then direction of R with F2. Remember, my dear student, resultant of the two forces, very important lesson. We find summation of the two forces or resultant of the two forces which act at 2 points. Look at, my dear student, important theorem. Look at, my dear student, the sum of moment of a finite number of parallel coplanar forces about any point in its plane is equal to the moment of the resultant of these forces about the same point. Look at this example. Two parallel forces of magnitudes 20 and F newtons act at the 2 points A and B. The magnitude of the resultant is 35 newtons. What is the distance between and the distance between the lines of action of the known force and the resultant is equals to 15 centimeter. What is the required? Find the unknown force F in each of the following two cases. Look at the first case, the known force and the resultant are in the same direction. The second, force and the resultant are in opposite direction. My dear student, look at solution. We have F1 and F2 in same direction and the R also same direction of the two forces. The line between F1 and R 15 centimeter. Therefore, we let C unit vector in direction of resultant. Therefore, we deduce from result from given resultant equal 35 C direction, and the known force F1 equals 20 C vector. Look at, my dear student, in this case we can find F2 by subtract 35 minus 20. Why? Because when the two forces are parallel and like, R equals F1 plus F2. Therefore, R equals F1 equals what? 20. 20 plus what? Equals 35 equal 15. Or 35 minus 20 equal 15. Therefore, we can calculate F2 by subtraction R minus F1. R equals F1 plus F2. This is rule. But in this case, F1 20C, F2 also equals 35 minus 15 minus 20 equal 15C. The sum of moment about C is equals to moment of resultant about C equals 0. Therefore, my dear student, remember what is the meaning of the sum of moment. Sum of moment equals R times F, R1 times F1 plus R2 minus F2. But look at the direction. The direction of the moment, anti-clockwise positive, clockwise is negative. Then the force times distance, 20 times 15 minus 15 times BC must be equal 0. This theorem. Therefore, we find BC equals 20 centimeter. The force F2 acts as a point at a distance of 35 centimeter from point A. The second required, find the unknown force Fr and F1 in opposite direction. Look at the opposite figure, my dear student. Let's see unit vector and direction of resultant. We know that from given R equals 35C and F1 equals negative 20C. Why? Because F1 opposite R. We taking C vector and direction the resultant R vector. Then we deduce that R vector 35C vector, but F1 equals negative 20C vector. Therefore, my dear student, R equals F1 plus F2. Therefore, 35C by substitution about R and about F1, negative 20C plus F2. What to deduce? F2 equals summation of 35 plus 20. Therefore, F2 equals 55C direction. Remember, my dear student, this rule we can calculate F2 by more method. We can find F2 equals R plus F1. We know that moment at a point equals 0. Sum of moments of parallel forces must be equal 0. 20 times 15 minus 55 times BC must be equal 0. To find the BC equals 60 over 11. Therefore, F2 acts at a point B at a distance 105 over 11 centimeter from the point A. Another example. Look at, my dear student. F1 and F2 are two parallel forces act at a point A and B. F1 equals 4 Newton, F2 70 Newton, AB equals 50 centimeter. Find the resultant of F1 and F2 if we have two required. They have the same direction. They have two opposite direction. Solution. My dear student, look at the first required. What is the resultant of the two forces 40 and 70? 40 acts at A, 70 acts at B. Distance between them, A and B, equal 50 centimeter. we suppose AC equal X, then we deduce that BC 50 minus X. This is graph to express about example. F1 and F2 are equal summation equals 110. Why? Because in same direction. R equal F1 plus F2. Why? Because F1, F2 are parallel coplanar forces, and R equal summation of the two forces equals 110 Newton. Then by cross 40 times X, or F1 times AC equals F2 times BC. By substitution, 40 times X equals 70 times 50 minus X. Divided each term by 10, therefore we deduce that for X equals 350 minus 7X. By using like terms, 11X equals 350. What is the value of X? 350 over 11. From end A, we know that C belongs to AB, AC 350 over 11 centimeter. The second required, F equals F2 minus F1 equals R. Look at, my dear student, R with the biggest force, 70. Therefore, we know that F2 more than F1. Then R equals 30 by subtraction 70 minus 40 equals 30 Newton. Therefore, my dear student, by using cross or distant AB times F1, we know that the force F times AC equals the force 70 times BC. Therefore, we reduce 40 times 50 plus X, inside bracket, equals 70 times X. Divided each term, like hand right by 10 and left hand right by 10. Left hand side divided by 10 and right hand side divided by 10. We deduce that 200 plus 4x equals 7x. Therefore, 3x equals 200. What is the value of x? 200 over 3 centimeter. Then the resultant act at 200 over 3 centimeter from the end B. My dear student, by the end of the lesson, I am very happy to spend such time with you. Thank you. Goodbye.